Okay, for today's homework, I've made a video going through the steps just so that you can see a few more examples of how to calculate the different information here. So if you're looking, I want you to do 3, 4, 5, 6 to practice. So if you're looking through here and just quickly scan through, the first one is you have to find the amount concentration. The next one, it says find the mass. So you have to find the mass here. And then the one after that is what is the volume? Okay, so be able to calculate these things. So this one's concentration, this one's mass, this one's volume. Okay, and then again, this one here is volume as well. So our two formulas that we know are C equals N over V. So again, you can manipulate that to find the volume, you can find the concentration, you can find the amount. And then we're still using this one from last unit where whenever we take the mass and divide by the molar mass, we can get amount. So whenever we need to find the mass, we can use this equation, right? Whenever it's volume or concentration, we can use this one, okay? But we're going to use these together a lot of times. So yeah, be able to rearrange them and just calculate what you need, okay? All right, so the first one I'm going to do here is question 3. So I already started here. I have the question here. We're reading through. We have silver nitrate solutions are sometimes used to determine the salt content of food. What is the amount concentration of 500 milliliters of the solution? And we know that it contains 34 grams of silver nitrate. Okay, so those are the given pieces of information. So again, we're going to convert this to liters. Okay, so don't forget to always change the volume to liters when we're calculating the information today. Okay, so we're dividing by 1,000 here. All right, the mass in gram is good, and we're gonna we need to find the amount concentration. So let's look at our plan of what we will do here. So we need, in order to find concentration, we need this formula. So I'm just going to write it on the side here. So we need this formula to calculate the concentration. So I need the amount and the volume. Well, I have the volume. I don't have the amount because right now it's in mass. So in order to find the amount, you're going to use your mass. You're going to divide it by the molar mass. And then you can use it to put it in here, divide by the volume, and you get your concentration. So this is the plan, okay? All right, but before we keep going, we need to find the molar mass of silver nitrate. So we'll just do that really quick here. Okay, so we have all the information now that we need in order to get to calculating here. So we'll start off with our first step here. We need our mass divided by our molar mass. So our mass was 34 grams, and we're going to divide by our molar mass, 169.88 grams per mole. Okay, and we will get the amount of silver nitrate is, okay, and again carry extra digits here and just keep that value in your calculator as well. All right, so that's step 1 is done. So now that we know the amount, we can plug it into our formula here for concentration. So in order to find concentration, we need to take the amount of moles and we divide by our volume. And our volume has to be in liters, which we've already converted here. And the reason why, if you're wondering why I wrote so many zeros like that after the 5, is that see how this has 1, 2, 3, 4 digits. Okay, so zeros that trail or come after do count. So 1, 2, 3, 4 digits are important. So 4 digits will still be in this value as well when I convert it to liters, okay? All right, so now we're going to divide that, and our concentration of silver nitrate solution here is 0.4. Okay, so now that we're looking at concentrations and stuff like that, we're always we're describing a solution here, okay? So it's no longer like this powder or solid and so forth. Okay, so this is the concentration of 0.4, and now I'm looking at digits. So this one had 4 digits that were important. This one only had 3, so that's what's going to determine what the answer will have, just 3. So leading zeros don't count, but 1, 2, 3. This one's not bigger than our 5 or greater, so that's all we need here. And then now I have our concentration, and I can make a therefore statement. Therefore, okay, so you want to use the proper terminology, amount concentration. That's important too, to write amount, not just concentration, but amount concentration today, because you're going to be looking at other types of concentrations. And you need to be clear as to what you found or what type of concentration you found. So the amount concentration of silver nitrate is 0.4 mole per liter. Okay, all right, so that was the formula method. I'm going to just show you quickly, maybe right here, how to do the unit analysis method, okay? Just because that doesn't take as much space. So again, we're going to have all the stuff that we were given here, okay? But our plan of attack is different. So our goal here is to find the concentration of silver nitrate. So again, this is the unit analysis method. Okay, so we need to find the concentration of, silver nitrate. So we're going to take again, we have a couple values here, and we're trying to figure out what to use first. So again, liters, use it at the end, okay? So just take your mass, so your 34 grams of silver nitrate, okay? And then again, what our plan here is to go from mass to moles, okay? So we need to use our molar mass. So our molar mass was right there. So again, we're going to flip it. Okay, right, 169.88 grams of nitrate, silver nitrate. Okay, so again, if we here, when in doubt, just start kind of canceling out. Okay, those two are gone. So now I just have moles. Remember, concentration is in mole per liter, so that's our goal. Okay, so now that leaves us with just the liters information that we have to use here, and that's right there. So we're going to divide by 0.5 liters, okay? So then that'll get mole per liter. So now we have 34, all divided by 69.88 and the 0.5 underneath. Okay, so that comes out to a concentration of silver nitrate, 0.4 mole per liter. Okay, so there is the same A and S step as above here with the formula method, but it just, just a little quicker here, and then you write your final statement, okay? All right, so let's move to the next example. All right, here's the next practice question. So again, read through, write down all the information you have and what it is that you have to find. Okay, so again, you should, when you're reading through the information, you should be looking at what type of like units that the numbers have, and that should be a clue as to what information you have, okay? So we have 2 mole per liter solution. Okay, so mole per liter, that's concentration of potassium hydroxide. And it's used to precipitate a toxic metal ions from industrial waste. So you've seen that in your single displacement or even double displacement type reactions, where we're trying to mix some solutions together, and sometimes one of them will form precipitate, so a solid that can be scooped out, okay, and removed from some waste here in this case, so it's not being dumped into the environment. So that's why there's advantages of trying to predict what's going to create a precipitate, so that we can grab the say the metal that we don't want. Okay, we want to make it into a solid, and then we can scoop it out. So it's kind of a neat process here. Okay, so we are trying to find the mass of potassium hydroxide. Okay, so we have a concentration, we have a mass, and we know the volume of the solution. So it's 1.5 liters. Okay, all right, and again, we're already in units, the units of liters, so we're good. We don't need to convert this, so we're good. So we know the volume, we know the concentration, we need to find the mass. Okay, so here's our plan. So again, here are the formulas. So you know there's concentration. Okay, there's concentration that we've always been using. So we have the concentration, we have the volume, right? But we need to find the mass. So how do we find the mass? Well, we've always used this formula here to find the mass. So what we need to do here is, since we have the concentration volume, we're going to rearrange this. So we'll put this over here so that we are going to find the amount first. Okay, once we find the amount, then we need to find the mass, which is this one here. So again, we're going to rearrange this one so that mass is equal to amount times the molar mass. Okay, so that's our plan. We're going to calculate the amount, then we're going to use it in here to calculate the mass. Okay, so the last thing that we need here is we need to quickly find the molar mass of potassium hydroxide, and potassium is 39.10, oxygen is 16, and hydrogen is 1.01. So let's add that up. Okay, and we get 5611 grams per mole. Okay, so we have the molar mass now. All right, so let's put our plan into action here. So we have to find the, not the concentration, we're going to use this one. We're going to use the amount. To find the amount, we need to multiply the concentration times the volume. Okay, and then, so that's the first part. Then we're going to use this part now to find the mass. Okay, so the amount is 3 moles. The molar mass is 5611. Just multiply those together. And you end up with 168.33. And again, see the moles cancel out, so we have mass left. Okay, now I'm looking and analyzing the digits here. So 2 digits here, 2 digits there. So we need to get this to 2 digits. So this is the tricky part. So this is why I'm not going to pick on you for rounding, but to get this properly to 2 digits, so this is for the physics students too who've learned sig figs, I need to only have 2 digits here, so I can write this in scientific notation. So here, I'll write it as scientific notation first, and then I'll round it. Okay, so 1, 2 spots over. Okay, so 1.68, so here, if I leave all the digits there, 1.6833 times 10 to the 1, 2 moves here. So you can write this in scientific notation, and if you need it down to 2 digits, that's how you get it to 2 sig figs, okay? Anyway, if you leave your answer like this, I am not going to, take off marks in chemistry, okay? All right, so, yeah, just I wanted to kind of keep trying to show you how to find the sig figs here, significant digits here, just so that you're not seeing it for the first time, okay, later on in your science courses. All right, so therefore, you have the mass of potassium hydroxide is 1.7 times 10 to the 2 grams, or 168.33 grams is fine as well. Okay, all right. So that is your formula method. So I'm just going to quickly do the unit analysis here. So you're given, your required's all the same, but your action plan is different. So again, your goal is to find the mass of potassium hydroxide. Okay, so you're going to start with the concentration first. Okay, and then from there, you're going to, so since you have your concentration, in order to get to the moles island here, you need to use your volume. So what we're going to do here is we have our volume of 1.5 liters. So you have to determine where you're going to stack it. So you're going to put it at the top because you want the liters to be on opposite ends, I guess. So this one's at the top, that one's at the bottom, or so this one's at the bottom. Okay, so from there, that'll nicely cancel out the liters. Okay, all right, and then from there, you need to, so you're now at the moles island, okay? So you need to go to the mass island by using your molar mass. So we got to figure out how to put in our molar mass here. So it's 5611. So I already have moles at the top, so I want to keep moles at the bottom. I'll keep the 5611 at the top of the mass, and then you'll find that that nicely cancels out the moles like that, and then just leaves grams, which is what we want. All right, so 2 times. Okay, and you end up with what you had above with the formula method. Okay, so there it is, and again, I'm just converting it to scientific notation so I can get 2 digits here. And then there's your mass, okay? And then write your therefore statement. All right, next one. So we have number 5. Okay, question number 5. Sodium carbonate can be used to regulate the acidity of swimming pools. We need to find the volume in milliliters of a 0.45 mole per liter solution that contains 35 grams of sodium carbonate. Okay, so again, it won't literally say here is the concentration. Sometimes it'll just say 0.45 mole per liter solution. So they usually write 0.5 mole solution, mole per liter solution. So they won't literally explicitly say concentration. So you got to be able to recognize it by the unit here. Okay, here same with this one here, we know grams is mass. Okay, so from the units here, you should be able to go, oh, that's C, that's M. Okay, and then here, the only word that it's clearly saying what it wants is the volume. Okay, so that's how we know volume. So just, again, practice so that you know when you see concentration, you know when you have a mass and so forth. All right, so here's our, I have the molar mass already going for sodium carbonate. Okay, so here's our plan. So when in doubt, like if you don't know what to do, you just write down the formulas, the 2 formulas that we have been using so far. Okay, so these are the ones, like this one we used a lot in last unit, and this is the new one for this unit. Okay, so for what you want to do here is, well, you need to find the volume. Okay, so you need to find V here. So let's rearrange this so that we can find V. So again, what I'm going to do is I'm going to move this here. Okay, and then I'll move the C out of here. So because I want V all by itself. Okay, so I rearrange them. So a lot of people know just to switch these 2 here. Okay, so here's the volume formula. So I need the volume formula, so I need the amount divided by the concentration. I have the concentration, I don't have the amount though. So that's where we're going to use this formula. So this one's already the right way. So I'm going to use the amount, calculate that, then I'm going to find the volume. So this is the first step, and then that's the second step, okay? So that's if you're having a bit of trouble as to, if you like using the formula method, but you still just don't know what to do, throw them both down and go, okay, I have to find volume. Here it is. So in order to find volume, I need N over C. Do I have N? No. So you're going to use this one to find N first, using your mass, which you have, and your molar mass, which you have. Okay, calculate your amount, then throw it in here, divide it by 0.45, and then you get your volume. All right, so here's our action plan now. So we're going through, we're going to calculate our amount first. Okay, so we're going to do that by taking our 35 grams of our sodium carbonate and dividing by our molar mass. Okay, so I'm just carrying a few digits here, not all of them, but just keep that number in your calculator. So we found the amount of sodium carbonate. So now I need the concentration, sorry, we need the volume. So we're going to use this formula that we rearranged. And we're going to go amount divided by concentration. Okay, so mole divided by 0.45 mole per liter. Okay, and one thing here I'm just going to add is it wants it in milliliters eventually, okay? All right, so we're going to take this number, divide by 0.45 mole per liter, and then we'll get to our volume. 2 liters, okay? So if we go through, we have 2 digits here, we have 3 digits here, so we just need 2 digits in our final answer. That, okay? All right, but then also we want to convert this to milliliters. So we're going to times it by 1,000, okay? And then we end up with, that value there, but again, we need the 2 digits, so we would have to go to scientific notation in order to write it with 2 digits like that, okay? But again, if you left it as 733.82 milliliters, I would be okay with it. I just rather that you know how to calculate something instead of being able to show me how you know how to round something, okay? All right, so here is the volume of sodium carbonate. So the key word, the volume of sodium carbonate is 7.3 times 10 to the 2 milliliters. Okay, all right, I'm going to show the unit analysis method here right beside. Okay. Okay, so we need to find volume. That's our goal. So you're going to take your information that you have here. So we have our concentration and we have our mass, okay? So we need to think of our plan here. What are we going to do? So we have our mass, so we need to go from mass to moles, and then we need to get to volume. So we're going to use the concentration somehow to jump to the volume island, okay? So the jump to here and then jump to here. That's what we need to do. So we'll start off with our mass, use our molar mass to get to moles. So our mass is 35 grams. Okay, our molar mass, so we're going to flip it. Okay, so we get to there, and again, you can see that we're on the right track here because the mass units will cancel out. So now we're in moles, and then we want to get to the volume, so liters, right? So our next number we're going to use, like I said here, we're going to use the molar mass to get to the moles island, and then we need to use concentration to get to the volume island, okay? So we need to look at concentration here and see how it's mole per liter. So we are going to stack this so that they don't clash. So mole per liter, so mole will have to go here. So it'll be 0.455 moles, and then the 1 liter will be up in the air like that. So we flip the concentration, okay? So when we do that, we're going to end up with canceling out, right, the moles here and the moles here, and then that leaves us liters, which is what we want, okay? So that's why, yeah, this method is quite efficient because if you can't remember exactly the way the formulas are supposed to go, you can just use the units and adjust them so that it gets the units that you want, liters, and then it cancels out everything else. All right, so 35 divided by all the stuff at the bottom here. Makes 0.7338 2 liters. So rounded up, that's what it would be, but in milliliters, that's what it will be in milliliters. But then you can change it to scientific notation if you need it to down to 2 digits, like that. Okay. All right. So again, if there was more time, I would show you how to do scientific notation, but I'm going to write my answer like that because it's the proper way. But again, if you left it as 733.82 milliliters, that's fine. Okay, just make sure write volume as your keyword, and then write your answer with units. All right, last one here. Okay, so again, we need to find volume. All right, we have a solution of sodium oxalate. It's used to analyze the presence of calcium ions in water. Water quality tech people typically use 0.1 mole per liter solution for the analysis. What is the volume in milliliters that can be prepared using a 33.5 gram solid sodium oxalate? Okay, so we have some sodium oxalate powder. We have to get this concentration. This is the mass, so what volume can we produce? Okay, so from here I would have the molar mass. So again, here we are brainstorming. We're trying to figure out a plan here. So again, just throw down all the formulas that you know. Okay, so we know our amount concentration. We know our moles formula. Okay, so what is it that we have to find? We have to find the volume. So again, we need to isolate this for V. So we did that before. So it's like V and C just swap places. Okay, so there's the formula for volume. In order for us to calculate this, we need the amount. We don't have that. We only have concentration. So we're going to use the amount formula first, and then we're going to calculate the volume after with that formula there. Okay, so let's go through and fill these in. All right, so we have our mass of 33.5 grams, and we have our molar mass of 134. Okay, and then we end up with an amount of 0.25 moles. Okay, that's what I had on my calculator, but you should be writing more digits, so like 0, 0, 0, yes. All right, so there, step 1 is done. Step 2 is now to use this formula to calculate the volume. So we have our amount in moles divided by our concentration, which is 0.1 mole per liter. And that gives us a volume of 2.5 liters. Okay, and again, we want our units to be milliliters, so we are going to multiply by 1,000. To get to milliliters, and then we're trying to figure out how to round here. We have 3 digits, we have 3 digits here, so again, we have 2,500, how do we write it as 3 digits? You gotta change it to scientific notation. Okay, so then because that leading number now only has 3 digits, you are meeting the criteria for the significant digits, okay? All right, now, final statement. What is it that we found? We found the volume of sodium oxalate okay, is 2.5 times 10 to the 250 times 10 to the 3 milliliters. All right. Okay, and then just to finish off, here is the unit analysis method. Okay, so the A step is different from the formula method. So again, you know you have to find volume of sodium oxalate. So you're going to start with our mass. Go to moles, then jump to volume. So our mass is 33.5 grams. Okay, so in order to get from mass to moles, we need the molar mass. So we'll flip the molar mass here. So grams goes to the bottom so that it can cancel out. Okay, all right, so then now we're in moles. And so to get from moles to the volume island, we need concentration. So now we're going to look at this one and decide which way to flip that one. So again, we don't want moles and moles clashing, so we have to flip this to the bottom and then put 1 liters at the top. Okay, so moles is gone, and we're going to divide 33.5 divided by the 134.1 at the bottom to get to 2.5. Okay, and again, convert it to milliliters, and then if you needed to get it down to 3 digits, convert it to scientific notation. All right, and then write your therefore statement. Okay, so hopefully after seeing all those examples, this is why I always say, please practice, do the practice questions. Okay, don't just look at a couple examples and go, I think I got it. Okay, just you have to go through and practice a lot to see all the different scenarios and to see like what your brain will do in order to problem solve and what kind of plan that you can kind of put into place so that you can get to the answer and so forth. Okay, all right, so now once you've completed all these, hopefully you should feel confident. You can go and complete the checkpoint.